Viewers, you are welcome to my YouTube video today. I'll be solving the 7th question in the West African Examination Council 2023 past question, and the subject is mathematics. The sum of three numbers is 81. The second number is twice the first. Given that the third number is 6 more than the second, find the numbers. The B part of the question, given that the points P defined by 3, 5 and Q minus 5, 7 on the Cartesian plane such that R defined by x, y is the midpoint of PQ. Find the equation of the line that passes through R and perpendicular to line PQ. Now, to solve this question, I will make an assumption. Let the first, the second, and the third numbers be x, y, and z, respectively. Okay? From the first statement, the sum of three numbers is 81. So I'll say x plus y plus z equals 81. I'll christen this equation 1. From the second sentence, the second number is twice the first, meaning y equals 2x. I'll christen this equation 2. The third sentence, given that the third number is 6 more than the second, z is the third number, okay, and it is 6 more than, so I'll write 6 plus more than the second, and the second number is y. I'll christen this equation 3. Now, to solve these three equations simultaneously, I can either solve the equations by elimination method or by substitution method. There are other methods I can use equally. I can solve it using matrix method, but I just want to keep it simple, okay? Now, the easiest route is to look at equation 2 critically. You see that in equation 2, y has been made subject of the formula, so I can easily make use of that, okay? So I'll substitute equation 2 into equation 1. If I do that, equation 1 now will be x plus, excuse me, y has changed to 2x. I'll replace y with 2x in equation 1. So I have 2x plus z equals 81. Now, this is equation 1, but it has changed to another new equation because the position of y has been replaced by 2x. So I'll christen this equation 4. X plus 2x is 3x plus z equals 81. So this is equation 4, right? Next, I'll substitute the same equation 2 into equation 3, okay? So I'm using substitution method to reduce these three equations to two equations that I can solve simultaneously, okay? Now, if I substitute equation 2 into equation 3, I'll have z equals 6 plus, I'll replace y with the value of z in equation 2, which is 2x. Now, I'll christen this equation 5 because 5 was born out of equation 3 with the value of y replaced with what? 2x. Okay? Now, I will rearrange this equation to look like equation 4. So I'll have 2x minus 6, or rather minus z equals minus 6. Now, how did I arrive at this? This is my equation 5, okay? What I did was to subtract z from both sides of the equation. So if I subtract z from the left-hand side of the equation 5, I'll have 0 there, right? If I subtract z from the right-hand side here, I'll have 6 plus 2x minus z. Now, I want to separate the constant term, which is 6, from the values with the variables, that's the x and z. So I'll subtract 6 from both sides of the equation. Recall that I have 0 at the left-hand side, and the right-hand side I have 6 plus 2x. So if I subtract 6 from both sides of the equation, the left-hand side will now be minus 6. Whereas the right-hand side will be 6 minus 6 is 0. So I'll be left with 2x minus z at the right-hand side of the equation. Now, if I rearrange, I can say 2x minus z equals minus 6. Just like if I have x is equal to 2, I can say 2 is equal to x. It's acceptable that way. So I just rearranged it to make it look like equation 4, and it will help me in solving the problem using the method that I will decide to make use of. So looking at equation 4 and 5, I can solve them simultaneously. Here I will decide to solve by elimination method. You can decide to solve by substitution method. In some of my previous videos, if you go through, you'll see one of those. I solved the simultaneous equation using both methods. So it may be good for you to go take a look at some of those videos. Okay. Now, solving this problem by elimination method, I'll bring out equation 4, which is 3x plus z equals 81. This is my equation 4, and then equation 5 is 2x minus z equals minus 6. I'll christen this equation 5. Looking at these two equations, by elimination method, it means you eliminate one of the variables and then you get the other one. Okay. So if I want to eliminate z here, because the coefficient of z in equation 4 is plus 1, and the coefficient of z in equation 5 is minus 1. So it's easier to eliminate z. If I want to eliminate x, I have to make the coefficients of the value, of the two x, of x in equation 4 and x in equation 5 to be the same. So I have to multiply through by a constant, but I wouldn't want that because that's another difficult route to toe. So I would rather eliminate z in equation and in the two equations. So to eliminate z, all I need to do is to add, so that plus times minus is minus. So plus z minus z is 0. Okay. So 3x plus 2x is 5x plus z plus times minus is minus. So plus z minus z is 0. I'll have my equality sign. 81 minus 6 is 75. If I divide both sides by 5, the coefficient of x, so I'll have x equals 75 divided by 5, which boils down to 15. Okay. Next, since I've gotten my x, it's easier for me to get y, because from equation 2, I know y equals 2x. So I can substitute x equals 15 into equation 2. If I do that, I'll have y equals 2 times x, and my x already is 15. So the product of 2 and 15 is 30. So I've gotten my x, I've gotten my y, remaining z. Okay, so to get z, I can substitute y equals 30 into equation 3. I can use equation 3 to get z. I can equally use equation 5 to get z, but I just decided to use equation 3. It looks simpler. Okay. Z will now be equal to 6 plus the value of y. I've gotten y to be 30, so I'll substitute it. 30 plus 6 is 36. Therefore, from the solutions so far, I've gotten the value of x to be 15, y is 30, and z is 36. Therefore, my x is 15, y is 30, and z is 36. Okay. I'll move to the second part of the question, the B part. Now, from the B part, the first statement states that given that the points P, 3, 5 and Q, minus 5, 7 are on the Cartesian plane, such that the point R, defined by x, y, is the midpoint of PQ. Find the equation of the line that passes through R and perpendicular to line PQ. So I'll say let P be equal to the coordinate of the point x1, y1. So what I'm trying to say here is that I'm assuming x1 to be 3 and y1 to be 5. And then I will say let Q, defined by minus 5, 7, be Q, such that Q is defined as x2, y2, meaning x2 equals minus 5 and y2 is 7. So if I make that assumption, I can use that to find the equation of the midpoint of the line segments. And which line segment am I referring to? Line P and line Q. And remember, I've defined P as x1, y1 and Q as x2, y2. I can go ahead to make use of the midpoint formula to solve this problem, but I just want you to have a generic form of generic equation of the midpoint to find the midpoint of a line segment. Okay, that was why I had to use x1, y1 and x2, y2 to represent point P and Q respectively. Therefore, R, which signifies the midpoint of PQ and defined by x, y, will now be equal to x2 plus x1 divided by 2, y2 plus y1 divided by 2. So this is the equation of the This is the formula for finding the coordinate of the midpoint of a line segment when you have 2 points with their coordinates given. So I'll substitute the values of x2. X2 here is what? -5 plus x1 is 3 divided by 2, comma, y2 is what? 7 plus y1 is 5, as you can see, divided by 2. So the coordinate of r will now be -5 plus 3 is -2 divided by 2, comma, 7 plus 5 is 12 divided by 2. If I reduce this fraction, the coordinate will now be -2 divided by 2 is -1, 12 divided by 2 is 6. So the coordinate of the midpoint of PQ is -1, comma, 6, meaning that x in r is -1 and then y in that r is 6. To find the second part of this question, they say find the equation of the line that passes through R and is perpendicular to line PQ. Okay. Now I need to find the gradient of line PQ. So I will say let gradient of line PQ, let it be MPQ. If that be the case, using the point P and point Q, I can get an equation for the gradient of the line PQ to be y2 minus y1 divided by x2 minus x1. This is how to find the gradient of a line where you have 2 points, the coordinate of 2 points along that line. Okay, 2 points that are on the same line in question. And here we're given the coordinate of P and Q. So if I substitute appropriately, y2 is what? 7. y1 is 5, so it will be -5 divided by x2 is -5 minus x1 is 3 -3. So I'll have 7 minus 5 is 2 divided by -5 minus 3 is -8. So plus divided by minus is minus. So I have -8. If I reduce this fraction, it boils down to -1/4. Now I will make an assumption. Let the gradient of the new line, which line am I referring to? The line that passes through R and that is perpendicular to PQ. Let the gradient be MN. So if two lines are perpendicular, the product of their gradient should be equal to -1. So MN or M subscript N multiplied by M subscript PQ should be equal to -1. If I make MN subject of the formula, I will have -1 divided by the gradient of MPQ, which is -1/4. Now, if I solve this, minus times divided by minus is plus. If I change this division to multiplication, this fraction, I'll have to use the inverse. And the inverse of the fraction will be 4/1. 4 times 1 is 4. Minus times minus is plus, so I'll have plus 4. Now, the gradient of the new line is defined as y minus y3 divided by x minus x3. I know you're wondering, how did I arrive at this formula? It's synonymous to this formula, but in this case, I have a gradient, which is Mn. I have the gradient of the new line, and I have a point through which this line passes, which is equivalent to the coordinate of the midpoint R, defined by -1, 6. So I will christen this value as x3, y3. So my x3 will be -1 and y3 will be 6. So if I substitute appropriately, Mn is 4. So you can see I just wrote it here so that you understand the values for -x3 and y3 to be -1, 6. So if I substitute 4 for Mn, I'll have 4 equals y minus y3 is 6 divided by x minus x minus times minus is plus, okay, and x3 is -1, so minus times -1 is +1. So if I cross multiply, 4 is a rational number, it's same as 4/1. Y minus 6 times 1 is y minus 6 equals 4. I'll open a bracket, x plus 1. If I open up this bracket, y minus 6 equals 4 times x is 4x plus 4 times 1 is 4. I'll rearrange this to look like y equals mx plus c. So y will now be equal to 4x plus 4. If I add 6 to both sides, this one will be equal to 0. So I have y equals 4x plus 10. This is the equation of the line that passes through R and that is perpendicular to line PQ. I do hope the solution was clear and you understood every bit of it. Okay, thank you for watching my YouTube video. Do subscribe if you've not. The name is Victorian STEM, and drop your comments if any. If you have any question, drop your comments, drop it at the comment section and I will respond to it. Kindly subscribe if you have not. Thank you and bye bye.